Hello and welcome to my tutorial on the nature of waves. Now, waves transfer energy from their sources. So a progressive or moving wave carries the energy from one place to another without transferring any material. Electromagnetic waves cause things to heat up. X-rays and gamma rays knock electrons out of their orbits, causing ionization. Loud sounds make things vibrate. Wave power can be used to generate electricity. Since waves carry energy away, the source of the wave loses energy. And so now we're going to talk about all the parts of the wave that you need to know. So if we have A, which is the amplitude, this is the length of the wave from the x-axis to the crest of the wave, or the very top. Now every wave has a uniform curve. This is just a sketch, and yes, it is very wobbly, so they always have the uniform length, and the wavelength is always the same as well. This is denoted by the symbol lambda. It doesn't usually have a circle around it. It's just that's the best example of the lambda logo I could find. So the wave always travels this way or that way, it depends, but usually in exam questions the wave is travelling to the right of your exam paper page. So distance is measured in meters, period is 2 seconds, frequency is F or hertz, or 1 over the time period. The phase difference is the amount which one wave lags behind the other wave. It's measured in degrees or radians. So this wave can lag behind the other wave like this. Let's do that again in another colour. So say that this is a wave. I do apologise for the crude drawing, but this could be an example of a phase difference, and this could be measured in degrees or radians as well. So on to the next part 3, how they could be reflected and refracted. Reflection is how the wave is bounced back when it hits a boundary, and the reflection of the water waves can be demonstrated in a ripple tank. And refraction is when the wave changes direction as it enters a different medium. This medium could be glass, it could be anything else that is slowing it down or speeding it up. So if it was glass, then the wave would slow down. So this one, when it goes through, its frequency can slightly change, but it's all is going quite slowly. But we'll talk about more about glass and how it affects waves in other tutorials. For now, we're going to look at their velocity. So this particular one, it can be derived from the velocity equation v equals d over t, which is the same as saying the velocity is the wavelength over the frequency, or 1 over the time period, or 1 over t as I represented there. This could be derived as v equals lambda f. That is your bog standard wave equation. So now we can apply what we've just learnt to a small question. So a boy floating on the sea takes 6 seconds to rise and fall once a full period of oscillation is completed. The difference in the height between the buoy at its lowest and highest points is 1.2 meters, and the waves pass at a speed of 3 ms minus 1. And the wavelengths of the waves could be either 14 meters, 16 meters, 18 meters, or 20 meters. And the amplitude of the waves could either be 1.2 meters, 2.4 meters, 0.6 meters, or 0.12 meters. So using the wave equation that I have just shown you and a little bit of rearranging, you can work out the wavelength and the amplitude of the waves So have a quick go at the question and come back when you're done. If you're still stuck, look at the video or have a quick Google, because Googling always helps for small things. Okay, hopefully you had a go at the question and you're ready for the answer. So let's delete this box and get on with it. So for part A, V equals lambda f and f equals 1 over the time period. So V minus lambda all over t, lambda is equal to Vt. So lambda is 3ms minus 1 times 6, which is 18 meters. So what I did there was times the velocity by the time in order to get the wavelength. So knowing that the height difference in height between the buoy at its lowest height and highest points is 1.2 meters, then we could easily divide this by 2, as that is the amplitude of 0.6 meters. So the trough to peak distance is twice the amplitude, so the amplitude itself is half. So let's just have a quick drawing in case you don't quite get it. I will probably use a ruler because it's proper practice to do such things. And I draw a quick wave like this. That's my buoy bobbing up and down, forming these nice waves. So the amplitude here is 0.6, and the wavelength, so from crest to crest or trough to trough, that's 18 meters, and that's what it looks like, and it's traveling at 3ms minus 1. So that's it for this tutorial. I hope you found this useful. More past paper questions should be up soon if you want more examples. Thank you for watching.